Along with flow rate, the total dynamic or manometric head, TDH, is another major parameter to be determined during an audit at a pumping site. After having measured flow rate, it will be possible to determine linear and singular head losses, values that are required to calculate the total dynamic head. Other data, such as an internal pipe's length, inside diameter, and material, will be needed in order to calculate these head losses, namely using a hydraulic calculation ruler. Even if measuring discharge flow rate is very similar at all pumping sites, the TDH values determined during energy audits vary according to the facility's setup. We will therefore consider three main setups: the case of a surface pump, the case of an immersed tube well pump, the case of a submersible wastewater pump. Let us start with a surface pump audit. In this setup, pressure must be measured at the pump's suction and discharge points, being careful where the measuring points are placed in order to install the manometers. The audit technician must also ensure that the difference in height between these two measuring points is taken into account when it exceeds 1 meter. Where the difference in height is under 1 meter, the TDH is calculated as follows. TDH equals measured discharge pressure minus measured suction pressure. If the difference in height between suction and discharge points exceeds 1 meter, the following calculation is used. TDH equals measured discharge pressure minus measured suction pressure plus difference in height. Let us now study the case of an immersed tube well pump, commonly known as vertical turbine pump. In addition to the discharge pressure, the dynamic level of the tube well must also be measured using a piezometer probe when the level is stable. The depth of water table is read on the tape measure, which emits a sound when the piezometer probe reaches the dynamic level. In this case, the total dynamic head is calculated as follows. TDH is equal to discharge pressure plus the static discharge head minus the vertical rise plus head losses. Also, TDH is equal discharge pressure plus elevation head plus head losses. Lastly, let us look at a submersible pump in a pumping and discharge station. At this type of site, the pump's startup and shutdown sequences are indexed to the effluent suction tank's level change. Very often, piezometric, ultrasound, or radar type level sensors are found in addition to float switches. The linear head losses to be calculated in a wastewater station during an energy audit are significantly lower than those identified in a tube well due to the difference in the depth at which pumps have been installed. The TDH is calculated as follows. TDH is equal to discharge pressure plus the static discharge head minus the vertical rise plus head losses equals discharge pressure plus elevation head plus head losses. What you need to remember. Depending on the type of site, the TDH calculation is not the same. In the case of a surface pump, the suction and discharge pressures are enough. In the case of an immersed pump in a tube well or a submersible wastewater pump, the TDH calculation takes into account the depth at which the pump was installed, the water body's level, and the linear head loss between the pump and the inlet where the discharge pressure is measured.